Optimizing cooling and lubrication systems in robotic machine tools is critical for precision, durability, and efficiency. As engineers, we must strategically balance fluid selection, delivery methods, and monitoring. Coolant selection comes first. Water-based fluids offer affordability and environmental advantages, but risk rust and microbial growth. Oil-based coolants, though more stable under thermal stress, introduce safety and toxicity concerns. Each choice demands a trade-off analysis based on operational load and material compatibility. Flow and pressure tuning is next. Insufficient coolant flow leads to overheating and tool wear. Too much causes waste and vibration. Precise calibration tailored to tool geometry and material hardness ensures effective chip removal without overloading pumps or causing nozzle erosion. Equally essential is maintaining system integrity. Filters, sensors, valves, and nozzles must be inspected regularly. Coolant pH, temperature, and contamination levels should be tracked to prevent degradation or machine damage. On the lubrication side, selecting the right oil, mineral or synthetic, depends on load, speed, and thermal exposure. Consistent film formation is key to reducing friction and wear. Automated systems with programmable intervals improve reliability and reduce human error. Routine checks on lubricant viscosity, contamination, and flow ensure the system remains effective. Condition monitoring tools and preventive maintenance schedules help avoid unplanned downtime and protect high-value assets. Ultimately, cooling and lubrication aren't afterthoughts. They are core to robotic machining success.